Hey guys, good morning. Hope everything's going well over there, and just wanted to see if we could get you some help on this distributive property topic here. I'm going to try and simplify things a little bit. My perspective on it is that we use distributive property all the time to make math easier. And as we move forward into the fifth grade curriculum and sixth grade, we apply the property almost unknowingly a lot of the times in our mental math, and that's one of the main things I try to teach, and we'll show you guys today. If anything comes up after the video and you've taken a look at it, if you have any other questions, just feel free to email me. We can talk on the phone, or we can post something else, or maybe try a different avenue. So I'm going to just try and run down the next 5 minutes what I might try and do in class. Obviously, you guys would be practicing along the way with that, so it's going to be a little quicker, but hopefully clarify a few things. So when we talk about distributive property, and these are some of the documents I shared with you yesterday evening. Sorry, trying to figure out how to get this on here. So when we show distributive property, we're talking about sharing, passing around, giving, providing an allotment. So in class, I might ask you guys to think about some ideas about what you know about distributing. And that can help us remember that with numbers in the distributive property, we are passing around or sharing one number over another using multiplication. And then we can add those values together. So it's the distributive property of multiplication over addition. So distributive property allows us to use numbers with multiplying and adding to simplify things. And I kind of put on the bottom corner here, it says sort of like expanded form, you can see there. So we might express the number 123 as 100 plus 20 plus 3. So we've broken that number up into some simpler parts to express each place. And then the distributive property, we can use that to multiply and then add those values to find a product. So the distributive property shows us each part of values and can simplify because we can multiply and then add separately. We can look at some examples of how that might work. So what I did here was just broke down some numbers in different ways. So the top equation shows us 5 times 2 plus 5 times 3 equals 25. Of course, that is 10 plus 15. So that might be a traditional way of expressing a value like that in math. The second example shows us how we can distribute the 5 across the 2 and the 3 in a different way. So using the order of operations, of course, we could add 2 plus 3 in the parentheses for this example, and it would give us 5 times 5. Or we can distribute the 5 over the 2 to make 10. Then we can distribute the 5 over the 3 to make 15. And you can see it gives us the same example as our top value. So this is 3 different ways of looking at the same product, okay, on the far side over here. Sorry, everything's opposite on here, giving us 25. The distributive property here shows us that we can use the 5 over 2 different numbers, and then we can add those together. So the distributive property of multiplication over addition. So hopefully that might be an example of how we can apply this and make numbers simpler to look at. Okay, here might be an example that we would utilize in class to help us see how we can use this property to make our thinking a little clearer and use it in computation, which is where I think it's most applicable, and that we already use it probably maybe even on a daily basis if we're crunching numbers a lot. So you can see my first equation on top is just an example of 6 times 12, and we're pretty familiar with that. So this is something we might practice in class, something we know well, that might take a second to think about, but we can break it up into parts. Okay, so on the top example, 6 times 12 is 72. That's our product. Okay, writing this algebraically, we might express it as 6 times 12 using the parentheses, and that gives us 72. So that might look a lot like the last document I just showed you, showing the 5 times 5. Okay, we might also break this up then into 2 groups where we can take the 6 and the 10, and then the 6 and the 2. So here's kind of our expanded form. We have 10 plus the 2, which brings us back to our 6 times 12 is 72. If we can express that using the distributive property, it allows us to demonstrate that 6 times 10 is 60 plus 6 times 2 is 12. And if we add 60 plus 12, we get 72. So if we're trying to execute some mental math, we might be able to break that up into 2 parts that are friendly numbers. And I believe that's where the distributive property, especially where we're at moving forward, is most helpful for helping to crunch numbers. And that might seem pretty simplistic, so I kind of put an equation down here. I'll give you a second to think about, or if you want to pause and see how you could break this down. 6 times 123. Where on the surface that might seem a little intimidating, or we might want to get out a paper and pencil. We might be able to use the distributive property mentally to distribute this 6 over 123 to find a product. So take a second to think about how that might look based on the demonstration above, and then we can talk about how we might break that down. All right. So here's my way of showing how I kind of thought through this. Okay. So I took our 6 times 123 on the top, and I broke it down so I could distribute the 6 over each of these values. So I chose to use the places, the hundreds, the tens, and the ones. Now we could break this down any way we like, which they do on your practice page a little bit, which I'll show you last for that property. But I chose to use 6 times 100, which gave us 600. So I distributed the 6 over the 100. So I have 600. And then I distributed the 6 over the 20, which gave me 120. Then I distributed the 6 over the 3, which gave me 18. Okay? So I just used the distributive property over all these places, and this looks a lot like that expanded form from the very first page I showed you. 600 plus 120 gives me 720, plus my 18 gives me 738. Okay, so I might be able to use the distributive property to simplify some equations and break down numbers into components that I can use. So I distributed the 6 over the 100, the 20, and the 3, and I combine those to find my product, 738, or in this case, the sum, 720 plus 18. So hopefully that might be a useful application for you, or example and practice. Of course, in class now, we might think of some equations that we could create on our own. I might roll some dice. I might ask students to pick their favorite numbers, or just have a number jumble and ask them to set up some equations that show the distributive property in practice. We would do a few together, and then I might break them off individually and practice on their own. And then we would get to the practice pages in the book. All right. A lot of times people ask, well, why would I use this, or when might I see it? So I just came up with a real quick example using some familiar values for us here of where we might use the distributive property just mentally, quickly, without knowing it. So an example was, you and I go fishing. There's two of us. We each spend $5 on bait and $10 on lunch. So you can see on the bottom here, I set up the equation that says two of us, $5 for bait, $10 for lunch, a total of $30. So I distributed the 2 over the 5 and the 10. 2 times 5 plus 2 times 10 would give us a total of $30. So on the outside we have the people, and then in the parentheses we have the money we spent, each, 2 of us, on bait and lunch. So there's an example of distributive property that you might see or think of outside of your math book. All right, to wrap up here, because my video only has 3 minutes left, I just did a couple of the equations from the book to show you how to think about these. Okay, so number 1 there is 8 times 7 plus 23. And they're asking you to break that up into the 2 separate parts, so the distributive property versus showing them individually. So of course we would fill in the 23 on the far outside there to balance that equation. So 8 times 7 plus 8 times 23. And both of those, of course, are going to give us 240. Question number 3 here in the middle shows us 8 times 57 minus 8 times 7. Okay, so they're kind of flipping the script on us here, wanting us to balance the outside of this equation to show how we can apply this to simplify something. Okay, so we take away the 8 times 7, and we're just going to end up with 8 times 50. Because, of course, in the middle here, 57 minus 7, we're taking away 8 times 7. So all we have left is 8 times 50. All right, so I brought that down to show you that those both are going to make 8 times 50 and equal 400. All right. The last one, which used some different values, was number 14 that I chose, because it showed us that 8 times 99 equals 8 times 100 minus 8 times what? So 8 times 99 is 792. We could use the distributive property to figure that out. We could do 8 times 90 times 8 times 9 and add those together. But the example was 8 times 100 minus 8 times 1, which would be 8 times 100 minus 8, which would give us 792 on both sides. So as we're working with this property, we're looking to balance our equations. Just remember, the equal sign means both sides are the same weight or value. So we're just trying to make those equal or balanced. Okay? The operation is irrelevant. It's how we're combining the values or the digits, the numbers, to make a balanced equation. Okay, guys, I hope that was helpful. If you need anything else, please, like I said, get in touch with me. I have about 40 seconds left before my free trial runs out on this, so I am available to help out. Thanks so much for the questions, and I look forward to chatting with you again. Take care.